Okay, Anthony, so what is the topic of the day today?
Well, let's go through our high availability architecture.
Okay, sounds good.
We start out in this environment. We'll have two boxes. It's our traditional cluster. So we have heartbeats in between. We still need to connect our storage to the boxes. Along with storage, we have our network. So now that we have our environment, we're protecting an application. Application fails from one node to the other, all with shared storage. This is on one site, site 1. So this is local HA.
Or local high availability, right?
Correct, local
Okay.
high availability. Moving from there, customers expanding, they want to get a little bit further out. So another site, another node. So we're working with Campus Cluster.
Okay, so what's the requirements here?
Campus Cluster can work off of the same heartbeat infrastructure, so you still have to be able to connect to them. You need that same level of network, so you're connecting in as well. And now you also could have local disks to that site. The disks will be mirrored, so you have dual access, making sure everyone can see all the disks. The latency has the requirement that this isn't going to be an issue. But you're at an extended distance while still maintaining that same local cluster.
Okay, when you say an extended distance, about how far?
It needs to support, with latency, the ability to do mirroring without impacting the application.
Okay, so relatively short distance.
Correct.
Okay.
If customers don't have that relatively short distance but still would like this clustering, removing the connections to both sets of disks, you still need those disks, but now we're going to talk about a replicated data cluster. So rather than the storage mirroring, where everyone's connected to all the storage, now you still have that same connection, just locally. You can either do that at the array level or at the host level.
This is the replication you're talking about?
Correct.
Okay.
The replication, replicated data cluster. This replication requires that you have synchronous replication. It has to be close enough that you can write from the application directly through the array to the other array, come back and respond, or through the hosts.
Okay.
But it is still a local cluster. All failover goes from node to node to node. Our final architecture is DR, so disaster recovery. In this instance, we no longer have one cluster. We have two separate clusters per site. One cluster locally here, one cluster locally here. You still have replication either at the host or the array site, but it's no longer synchronous because it's not close enough. Now you're doing asynchronous. It's different in that we're going through and writing down from the application to the storage array, and the storage array will replicate out or through the host do that same method. It writes out as it can.
Right, so it does the write in an asynchronous mode. It does it when it can do it. It doesn't have to do it immediately once it's written down to the primary disk, right?
Absolutely.
Okay.
And the difference here is that with each cluster being separate, they both understand the application, but only one can be online at a time. So if site 1 goes down, site 2 comes online. Site 2 goes down, site 1 comes online. When you switch over, you're also changing the replication.
Okay. So basically what I'm hearing from you here is our VCS product can handle all 4 of these different types of architectures with a little bit of different configuration, right?
Absolutely. Customers can move from a local HA configuration to a campus cluster or replicated data cluster, as well as extending it out to DR.
Fantastic. Well, thanks for explaining the different HA architectures that we have that our customers are going to be able to see. So
Absolutely.
Thanks a lot.
Thank you.